All right, everyone. Welcome to ASRG World Webinars, bringing you the latest in automotive research, innovation, and education. My name is John Heldreth. I'm the founder of Automotive Security Research Group, and we have a great presentation for you tonight. First of all, let me introduce myself. Once again, my name is John Heldreth. I'm the founder of Automotive Security Research Group, or ASRG for short. I've worked in the automotive industry for the last 15 years or so, and now focus my time on product or vehicle security. I'm originally from Detroit, Michigan in the US of A, go 313, but today I'm living in Germany and working at Porsche Engineering. Please feel free to follow me on LinkedIn and other social media platforms. Today, I'm not alone though. Today, I have a co-host, Patrick Lehnart. Patrick, would you like to introduce yourself? Patrick, thank you very much for being here tonight. Great. So first of all, let me quickly introduce Automotive Security Research Group. ASRG is a nonprofit company focused on the advancement of the automotive security industry. This is a community to support the coming together of two areas of competencies, the IT security market and the automotive market. This is a community for you, for the automotive engineer, for the IT security specialist, for the beginner, for the hobbyist, even for the people that might be in the wrong YouTube channel. This is a community of volunteers. Our entire organization is built on the volunteer efforts of the administrative team, and of course, people like yourself, the people that have interest, the people that want to get involved. So we're trying to remove the boundaries that can occur in the automotive security industry. This could be like communication or borders or learning different ways to find information, understanding which solution is the best one, making better decisions, because at the end of the day, we all have the same goals in mind. We want to keep our customers, our families, our friends' data safe and secure, which can only be achieved together. If you want to get more involved, make an impact on the industry, start your own ASRG location, participate in a technical committee, or be a part of a project, please reach out to us. You can find out more about ASRG at www.asrg.io or send us an email at hello@asrg.io. Great. Well, guys, we have really a lot of cool stuff going on right now. And I know I'm really sorry that you couldn't hear Patrick on the audio. That's embarrassing. I apologize. We'll try and fix that for next time. Just quickly, ASRG by location. We have locations almost everywhere. So here's an overview of where we are. Please take a look. If you see somewhere that's near you where you want to get involved, you can definitely go. We use Meetup to organize these different locations. So please, go check out what's around you. If you don't see a location around you, let us know. If you want to get more involved, if you think your community itself would be a really good community for an ASRG location, let us know. Send us an email at ASRG or at information@asrg.io. And we can talk about starting your own location. Today, ASRG has more than 5,600 members. This is amazing. We have 34 locations worldwide in 18 countries. What I'd like to say here is also we don't push locations. The idea here is if you think ASRG would be interesting in your location, then we talk to you about starting your own location. We do not push locations. So everything here is the effort from yourselves, from the members, from the leaders, from the volunteers that take their free time to learn more about automotive security. We have really a lot of great webinars coming up. Next week, we have automotive product security from an attacker's perspective. Rafael Carpi is coming to us from Riskier. He's going to give us a great presentation. Really interesting stuff there. November 26th. I don't know exactly what the topic is, but Argus is going to be with us. And of course, they're going to be talking about something interesting because Argus is always having something interesting on the plate. December 3rd, we're going to be talking about the WP29 regulation as seen through real-life cyber attacks with Alan Kunar and Upstream. And Upstream, of course, has all the information and intelligence in the automotive industry right now. December 10th, 2020, TBD, we'll have Basti Crook with us again. He's going to be talking about risk assessment models and threat analysis, I believe. He's coming to us from ECUs. If you want to give us, if you want to present something, this is a community for you. So please just get in contact with us, cfp@asrg.io, and we can talk about what type of presentation you might want to give. We have a lot of presentations planned, actually until May or June next year. So we will be coming to you every week as an ASRG Worldwide webinar. All right. Without further ado, I have to introduce the man of the hour, Sergej Dechand, and he's going to be talking to us about modern fuzzing for automotive software. So without further ado, I'd like to introduce Sergej. Sergej?
Yeah, thank you, John, for the introduction. You should see my screen, right?
Yes, sir.
Okay, yeah, thank you very much for the introduction. Before starting with the talk, I just wanted to announce that this year we are hosting a little conference, just taking 3 hours to be more compatible with business hours. And the topics will be DevSecOps, Fuzzing, and Automotive, and it will be held on December 2nd. And we have some very interesting people from the automotive industry or usability research presenting how security testing can be done in a more efficient way. But today it's all about modern fuzzing, modern fuzzing for automotive software. So thank you, Patrick and John, for the invitation. And yeah, I'm really glad to be here. So a little bit about myself. I'm Sergej, the CEO and co-founder of Code Intelligence. And I have a little bit automotive background. Back in the days, I worked for Volkswagen Nutzfahrzeuge, the truck part of Volkswagen, and later switched to the security and privacy area. And usable security and privacy basically means that it's a research field where you try to combine the aspects of the human aspects and the security, and this way create better approaches how to assist people and being secure at the same time. And I worked for the University of Bonn and Fraunhofer FKE, and there we had a few industry projects. And in the industry projects, me and two co-founders found out that fuzzing was the most effective weapon to find security issues in the software, but somehow no one in the industry was using fuzzing. So back on that idea, this is how Code Intelligence was founded as a spin-off from the University of Bonn, together with two co-founders, Khaled and Henning. And our mission became enable companies to bring their software testing to the next level. We started with fuzzing, but we use any kind of software testing techniques to make the life easier of the developers. Because what we are basically building is an assistant for a developer, helping him or her to develop a more secure and robust software. And this is exactly what drives Code Intelligence. I mean, every product nowadays, and today we are here at the automotive industry, there is a piece of software in every car, and it will get even more when autonomous driving will take over. And yeah, I'm convinced that fuzz testing will be a fundamental part how to achieve a secure and safe autonomous driving. So when approaching people from the automotive industry, we always ask the people about their knowledge about fuzzing. And I think about 10 to 20%, yeah, we hear like, yeah, fuzzy logic, I heard about that in the university, but it's not what fuzz testing is about. And fuzz testing is also not about just testing randomly. And I will show the advancements of fuzzing today and how to use it in the automotive industry as well. So, but we started about 2.5 years ago with the spin-off from the university. And back then, fuzzing was, as I said, no one really knew the advancements. But right now, it's changing because there will be the ISO 21434 advertising for fuzz testing, but also there is a lot of media coverage that there are a lot of advancements. So now it's changing. We get more and more people approaching us that they want to use fuzzing ASAP. And from the automotive industry, we hear that there are some challenges to introduce fuzzing. And this is exactly what we do. We help and enable companies to use fuzzing. So, I mean, most of the people here are probably familiar with the old testing approach, how traditional testing was working, basically manually. So you had unit tests, system tests, and manual code reviews to review all that code. And I mean, there is a huge advantage because we have brain power. We were able to find a lot of bugs and to create good tests, making sure that the software has a good quality. But at some point, there was a lot of competition and there were not enough developers. So somehow you have to make it more scalable. And as you know, fuzz testing, unit testing is on the one hand kind of time consuming. And on the other hand, developers don't really like to test the software. Often they want to focus on what they might achieve and don't like to focus on the edge cases. And based on that, two methods for software testing were born, basically the static and the dynamic analysis. And I don't want to go too much into the details, but let's just say with a few words, in static analysis, you can run the code without actually executing it, which is a huge advantage. But on the other hand, it's not really a testing technique because you are not testing the code. You are not running the code, but you just use heuristics, what is good and what is bad. And it's a great tool to write better software, but it's not really a testing approach. And on the other hand, there are dynamic testing techniques, and fuzzing is one of them. And yeah, the big advantage here is that in comparison to static analysis, it produces far less false positives because you always have an input which is leading to a crash or unwanted behavior. But on the other hand, it has the disadvantages that you have to do a lot of tuning, because you have all the kind of different interfaces, and you somehow need to give the random inputs or smart inputs to the software. And this is where there are a lot of changes right now. Since we are talking about modern fuzzing, let me make a short introduction what's actually happening with modern fuzzing. So there are some tech leaders, for instance, Google, they claim that they find more than 80% of their bugs with fuzz testing alone in comparison to all the other techniques. And they also have a lot of prominent open source examples for that. So they found over 12,000 bugs in the Linux kernel alone in the last 2 years, over 20,000 bugs in the Google Chrome browser, and over 20,000 bugs in 300 OSS projects maintained or very important for Google, showing the effectiveness of fuzzing in the large scale. There are also other players. For instance, Mozilla Firefox published a few numbers, and Microsoft is also leading the movement with the fuzzing. However, if we look outside of the tech leaders, for instance, like the more conservative industries, you see that fuzz testing is just beginning there, or not really available. And just to start what makes modern fuzzing is so unique or so effective, I just want to make an introduction of how fuzzing works and what kind of advancements have been made in the last few years. So it all started in the 60s with simple random testing. Basically, there were systems written in C or Fortran or whatever languages have been there, taking inputs from punch-in cards. And when you took the punch-in cards out of the bin and ran it through your software, you have the expectation that your software wouldn't crash. But when your software crashed, you basically found a mistake, an error in your application, and would fix the bug and make your software more robust to a different behavior. And then in the 80s, in the end of the 80s, it got a name. Basically, there was a real methodology behind that. In the University of Wisconsin, people started to create fuzzing engines, basically producing random inputs and giving it to a system under test over standard in. So it was used in Unix environments. And later it was extended to do the same with sockets or any other user interface. And there you basically created random inputs, ran it through your software. If your software crashed, you found an error. But obviously, to make it more visual, let's say we want to test an application simply showing images like a JPEG parser. If you would just create random inputs and run it through the application, you would handle a lot of error code of the JPEG parsing itself. However, you wouldn't get too deep in the code, because just producing randomly valid JPEGs or pictures basically would be very unlikely, and you would need an infinite amount of time and energy for that. So that's why in the 90s, people started, okay, we have some kind of manual testing from the unit tests, where we already have all examples for the application, and testing a lot of positive cases. What if we just randomly mutate some bits and bytes within those data, which could look like that or that, and and you run it through the application, and you would produce valid data, but also invalid data, which is kind of similar to the input expected, but not exactly the same. And if you run it through the image parser and the image parser would crash, you found more errors, you also get deeper inside the code. But obviously, it has a disadvantage because someone needs to provide a lot of sample data in there. And what if you forgot a specific kind of feature, which is hard to guess randomly, and so on. And this is how, from 2015, there kind of started a new fuzzing renaissance, basically that a lot of fuzzing techniques started to improve this a lot, because now we have the motivation to just start with a 0 without knowing anything about the application and produce valid data somehow. And the magic here is the instrumentation. You probably know instrumentation from your code coverage tools. So instrumentation is something like can be imagined as you put some additional markers in the code which tell an artificial intelligence what is actually happening inside the program, or in that case, the fuzzing engine. And this way you kind of help the mutation engine to produce more valid data. So let's say we start with the 0, basically a picture which cannot be shown, or which is an invalid JPEG, run it through the application, and then the markers, based on the markers in the code, you can get a feedback. So basically, you run the 0 through the application, and what happens in every JPEG parser is that it begins with or searches for specific magic bytes in the beginning. This way, it knows that now it got a JPEG file, and the markers notice all the bits and byte comparisons and give it as a feedback to the fuzzing engine. But additionally to that, you can give any other feedback, like what kind of path has been taken, what kind of code coverage have you achieved, how much memory you allocated, and so on. And this can be given to the fuzzing engine, and the fuzzing engine can then start to work with new predictions. So if it starts with these random bytes and search for those specific bytes, what if I just input the bytes in the beginning and run it through the application? Then you would notice, based on the markers, that in the application now you found a new state which you haven't found before. Okay, then you start make more mutations, preferably from that one, because right now you found a new path inside the application. And then adding some few more random numbers, you might get something like that. And then you flip a few bits and bytes and get something like that, like that. You can even combine it with some initial data, and then it could look like that. And this happens like thousands of times per second. And this way, you are able to achieve a far higher code coverage, but not only achieve, but also measure at the same time what kind of code you reached. So generally speaking, fuzzing is a technique, or the modern fuzzing is a technique how you would maximize the code coverage based on the behavior, what is happening inside the program. It doesn't really look for errors, but just for crashes. And as you know, if you have some buffer overflows happening, and the buffer overflows make a segmentation fault, you can even find things like that. But fuzzing can be combined with bug detection techniques. So you probably use tools like Valgrind, debuggers, or Google sanitizers during your development. And if you combine the fuzzing with those kind of tools, you are able to detect a lot of memory corruption bugs, undefined behavior, or any other kind of bug. And everything where you basically can write an assert for could also be found with fuzzing. So much for the introduction. You probably wonder how this works anyway. So let's say we have a very simple code here, because I was asked to give a little bit more technical talk today for the meetup. So let's say we have this simple function, just taking a number, and if the number is 100, you return 1, and else you return 0. So if you would translate it to the control flow, it would look like that. So, and if you compile it and have the assembly going on, so for the Intel platform, it would look like that. But now you want to have like markers in the code telling something for the AI. So what you basically add there is that you have additional calls, basically registering what is happening there. So and then you have basically different basic blocks. Every basic block gets a number, and this way you can even calculate what kind of path has been taken when you gave the last input. But why should you do that? It looks like very sciencey, and there are a lot of tools helping you with the unit test to provide all the different cases. So why should you add something like fuzzing in addition? So a lot of test automation tools fail there, because a typical program, like a font parsing program, would look like that, or even more complicated. So there, the tools run into various runtime problems and so on. But with the fuzzer, you don't care. You just run everything through the application, and then you go into specific branches. And every time you found a new branch, you basically improve and try to dig deeper and deeper within the application. So, and here, if you just measure what kind of path you have been taken, what if you have something like a bottleneck? So in the beginning, you have something that you are searching for a number which equals 100. So it's kind of likely to get this specific number if you would just brute force it. But what if you have a lot of cases? It would take too long. You can even improve the instrumentation. So here, every comparison could be improved, and you basically give every number or every string comparison back to the fuzzing engine. And then if you compare with some specific numbers, you can you would create them in the next rounds. And this can be even more complicated. So let's say you could do some arithmetic operations and so on top of that, and basically do it backwards then when you do the fuzzing. But let's not go too much into detail. I just wanted to show you like a complex example. So let's say we have a very simple data structure which has a string inside there and some specific number. And there is just one critical bug which is triggered if and only if you provide the number 1337, 1337, and so on. And then you also take a string, basically the test or the string bug hunter, and only if you provide the bug hunter string, only then you run into that critical bug. And with a lot of modern fuzzing tools, you can reach into such cases because you are able to use the instrumentation and dig deeper through the code. So with our platform, it takes you just less than a second to find the critical bug number 1 here, even though it's kind of complicated. And you see that you don't just return the normal numbers like the bug hunter, but the bug hunter is ran through the base 64 algorithm. So you basically did a few changes, and we still were able to find the input without knowing anything about the program in the beginning. Obviously, it has some limitations. If you have very complex arithmetic operations, so in the second example, to trigger the second bug, you have to provide an input code breaker because there you do some hashing. And obviously, to get into this kind of branch, you would have to break the hashing algorithm. So if you know how to do that efficiently, you could teach it the fuzzer. But this is basically like a limitation. If you have two nonlinear functions going on, converting the inputs, what you get, then you probably wouldn't reach those kind of cases. So this is basically a fuzzing in a very simplified manner. But we are talking about automotive today. So why should you use a fuzzing in automotive? So because of compliance, there are more and more internal guidelines and norms within the OEM manufacturers who want to use fuzzing and to have all their supply chain providers to use fuzz testing when they deliver software. And there is even the draft of the ISO 21434 basically giving fuzz testing as one method how to achieve a secure software. So it's kind of will become mandatory in the next few years to use fuzzing. But also there are OEM requirements, like they are moving to DevOps infrastructures and want to save a lot of costs. And this way, probably even the smart fuzzing, so the coverage guided fuzzing, what I have just presented to you, will become more important, because with the old dumb approach, where you basically did some random testing and all the protocol fuzzing, which is like the traditional fuzzing way, it's not easy to implement within a DevSecOps environment. And with the white box approach, you are able to basically connect this to your Jenkins, and during development you would find mistakes right away, right after committing the code. And I will show a little demonstration in the end how it would look like. So there is actually a fuzzing on the run going on in the automotives, because we already have a lot of customers from the automotive industry, and they are very impressed with the results. So, but obviously there are also a lot of open source solutions for fuzzing. And before getting in touch with us, a lot of customers or a lot of automotives also tried to get the open source running. And there are some automotive specific challenges which I want to address in this talk. So basically, automotive problems require automotive specific solutions, and I will just talk about a few anecdotes and a few challenges what we encountered when introducing the modern fuzz testing in the automotive industry. So let's start with one challenge. It's like the cultural aspect. So as you know, the V model is one of the most like successful things in the automotive industry. And the automotive industry is a conservative industry. Changes don't happen overnight. And now everyone is talking about agile, and the automotive industry is also switching to agile. They try to do sprints, they try to do stand-ups and so on. But still, the V model is kind of known by heart by every developer and by every manager. And as you can see in the V model, that you basically have a design, implementation, and then integration. And if you look on the time axis, it's a kind of sequentially. And it's really so one of the main reasons why modern fuzzing is not used widely from the cultural aspect is that you first need to get some developer and manager acceptance. Because if they used this kind of testing for years, and as you know, in the automotive industry, you have huge Q&A departments. There are specific security departments, but it's not one team. So it's all distributed over various departments. So there is no other way around except of during this time access. And with the DevOps movement, with the Agile movement, it actually starts to change, but it just takes a while. And the cultural challenge here is to get the acceptance of all the developers and all the managers. Also, in automotive industry, you have very complex supply chain and third parties. Sometimes there is a definition what a third party should deliver at some point, but the third party didn't deliver the code yet. So you need to somehow take that into consideration, and the code might not be running at some certain point. Or even worse, if a lot of parties are working together with the code and they have some specific responsibilities. So let's take as an example, like you have an OEM manufacturer having a large project going on, and then there are a lot of third parties contributing to the code, but on different parts of the code. And now you find a lot of bugs with fuzzing. So somehow it starts who is responsible for that bug, and then the game starts that you have to distribute it. And in other industries, there is no such a thing that they have such complicated supply chains like in automotive. But now, basically, the North Star of automotive industry, like the very successful supply chains, now become a burden in software development. So now they are in the middle of switching to the new aspects. Yeah, and obviously, based from the times where you did a Q&A, there is a hard focus on system tests. So basically, you have to have an entire piece of code running, put it on some hardware which does not run Linux or other operating system where bug detection is easier. And this way, you kind of get the hard mode in automotive to get it, because if you only find bugs in the system test, it's probably already too late and you already lost some time. And I mean, what we see again and again, that there are a lot of toolings in other industries which are quite successful, that they are not really used within the automotive industry. So one of the prominent examples is that you would find a lot of security issues just by using the Google address sanitizers alone. But in our experience in most of the projects, you see that those are only used by single users. It's not like everyone is using address sanitizer as, in the build. And yeah, basically, you kind of have to change the culture to adapt all the new tooling. But also, there are a lot of process and tooling challenges in automotive as well. So if we talk about DevSecOps, in automotive, it's just starting. But as you know, if you have like one department which is doing security only, another department which is doing the development, the third department doing Q&A, and the fourth department basically bringing all the people together, it worked in the past where you have been doing product development, but somehow there is a lot of friction in software development. And with all the hardware and software which has been considered in the loop, it's really hard to switch to the DevSecOps overnight. And I'm just joking to say, just if you take the good developers, the good security people, and the operations people together, but they don't operate closely enough, you have too much friction. So basically, you are not doing any DevSecOps at all, even though you have all the three components. And another very automotive specific challenge is all the tooling. So in comparison to other industries, there are a lot of commercial tools there. So in automotive, they use like operating systems which are kind of similar to Linux, but in a specific way. So I'm just taking AUTOSAR, adaptive AUTOSAR. They use compilers which are not compatible to C-Lang or GCC like in the other industries. And then you start to have challenges because a lot of security approaches are written for the standard tooling in other industries. And now it doesn't work for the automotive industry. So there you have to think about how to make it compatible. So there are also a lot of third-party libraries or protocols where you don't have the source code, for instance. And if you ever worked as a third-party supplier for a big OEM manufacturer, you probably know how hard it is to get access to the code. And if you have some tooling like which updates regularly, you also know the challenge if you have like a computer without internet access where the code is running, how hard it is to use different toolings there just because you don't have an internet connection there. And those are basically the challenges we encounter with many customers. But all the challenges might be, you could say that it doesn't matter. But as you know, the automotive industry struggles right now, and the budget, there are a lot of budget cuts. But if you would do the testing in the DevSecOps way and move to the more advanced techniques, you could save a lot of development costs. And if you take into consideration that software is becoming more and the bigger player, distinguishing the different automotive players, you definitely have to switch to those approaches. And we also see that happening. Yeah, so I also promised to tell a few anecdotes, basically what we encountered. And in the beginning, when we started with Code Intelligence, one of our first customers was DCSO, and they wanted to kind of introduce fuzz testing to an open source project, Suricata. And Suricata is an intrusion detection system. And this intrusion detection system is basically doing packet inspection for a lot of protocols, which are also used in the automotive industry, like Ethernet and TCP, UDP, and HTTP, and whatever. And there, they already used a lot of fuzzing tools. Like, for instance, they subscribe to the OSS fuzz platform from Google. Also, they used GitHub's CodeQL and so on. But still, when we applied our fuzzing engines there, we were able to find 12 like very 12 CVEs, and 6 of them were even critical, just because we wrote some protocol-specific features which were combining the coverage-based approach and protocol fuzzing in one solution. And basically the same things we try to apply in the automotive industry. Obviously, there are less open source projects from the automotive industry we can talk about here. And as you know, it's very hard to get a success story out there talking about an automotive security here. So this is why the next things will be anonymized. But just wanted to mention here, if you imagine that in this intrusion detection system, there are security professionals writing code for a security software, and then they fail to somehow find or still have complex bugs in those protocols. So why should the automotive industry people be better? And this is exactly what we notice. Protocol parsing or protocol handling is really hard, and it goes wrong in all kinds of projects, and it's not just in the security industry. So today I read that the Bitdefender did some file format parsing wrong, but it also happens in automotive as well. And probably the next example shows exactly this. So we were in a project for an AUTOSAR system, which already had all the penetration testing finished. They used some open source fuzzing solutions running for single modules. And also in this project, they used static code analysis and all the security things. And it got a successful penetration test in the end. And we tested this approach, and there was an IP interface at some point, and there we right away found five different bugs, and 4 of them were vulnerabilities, yeah, those were even critical. And this basically shows like that fuzzing can even complement people with penetration testing examples, because people make or penetration testers can also overlook a lot of things. And in most cases, the penetration testers are just hired and test the software without having any access to the source code. And this way, obviously, they won't get everything. And with a modern fuzzer, you don't have to take care about that, because basically you are instrumenting the code during compilation, and then at some point you test the software. Also, in this project, we just tested one of the 20 interfaces and had those kind of results, because later the customer started to use our software, but we were not in the process and don't know how much has been found later. And when we introduced our software there and started to talk about basically that we could test their IP stack in the as a single point of truth, just in a separate way, basically we started a lot of discussions with the developers that with this modern fuzzing approach, there might be some hardware issues, and we only tested the IP stack on the Linux system, and it's not really like representable, because there might be hardware issues and you wouldn't find the hardware issues. They are right. I mean, in our case, we have on Linux, on the other hand, we have far better abilities to find security issues, and this is a kind of optimization, because if you already are using fuzzing on the software and you find buffer overflows, they will happen on the hardware anyways. There might be some things which only happen on the hardware, but for this, you can still use the traditional black box fuzzing approach, or even better, if you record all the data from the IP stack during the white box approach, you could replay the data later in the system test again, but reaching a far higher code coverage, because with the white box approach you get better results. And yeah, it doesn't cost you anything, or it's quite cheap to introduce the additional fuzzing of single units which are running on the in software only. But yeah, you still get better results and have a more robust software. And also, we had a customer onboarding recently where we didn't have a pen test before, but they were using static code analysis already. They wanted to use fuzzing on some module levels, and we started with testing the most critical parts. Obviously, at the end, we also did some system level fuzzing, but within 2 hours, when we started the project, we found over 100 bugs in this module alone. Obviously, a lot of bugs would have been found later in the Q&A department. However, it was faster, and I will demonstrate it in a second, because they were able to get the results within their continuous integration inside their Jenkins, and see the bugs and the inputs producing those bugs right after the commit. And this way, it just took them a few hours to fix the bug, instead of having the entire process of 3 weeks when the Q&A department is finding those kind of bugs. And I always consider this kind of fuzzing like with those Pareto principle. With 20% effort, you find 80% of the bugs. I'm not saying you should get rid of the Q&A department, but there is a lot of room for improvement, how to do it better if you just have the fuzz testing as part of your development process. And you might wonder, now I'm talking a lot about fuzzing, what is Code Intelligence doing anyways? So we are basically building a fuzzing platform, making it in the automotive industry, but also in other parts of industries easier to use the modern fuzzing approaches. And for that, we built a fuzzing platform focusing on the 4 different pillars. And I would now demonstrate how it would look like. So if we say that we have an effortless DevSecOps integration, you can imagine it that if you are running your Jenkins or kind of GitHub Enterprise with GitHub Actions in your development process, you would see the results right after making this bug. And for this, let me share my entire screen instead of the tab. Just takes like a minute. Okay, so imagine that you kind of have a pipeline going on, and every time you make a new pull request within GitHub, you can run your traditional GitHub Actions pipeline automatically. So in the automotive industry, most of our projects are using Jenkins, though, but I think it's kind of cool to see it with GitHub Actions.
Hey,
so,
Sergej.
Yeah.
Can you zoom in a little bit for us?
Is it better now?
Yes, sir. Thank you.
Okay. Okay. So basically, what we see here is a merge request. Someone has changed the code, and what you basically would get is that your pipeline is not running through. You basically get something like, okay, I found a stack buffer overflow in that kind of code, and you could see even the details here, like, as you know from your Jenkins or any other continuous integration. So basically, we have two steps. Usually, you only build your software. In our case, you build and instrument it. So basically, you build it in the original way, and the second way that it's instrumented, that it can be used with modern fuzzing. And there, the software is built for the different kind of open source fuzzers. And also, we have some proprietary fuzzers from Code Intelligence, improving the results of the open source fuzzers. And you could get the result. But getting back here, you can even have more information. So it's something like you could have a look on the finding, why it occurred. Then it has high-level descriptions for the developer that the stack buffer overflow happened this and this way. Here we see that it was found with the address sanitizer. We also have other bug detection mechanisms going on. And it happened with those kind of bytes that this specific crash has been happening. But as a developer, you kind of want to understand the code better. And for this, we even provide shortcuts. So you could debug the code in your IDE. So in this case, it's the Microsoft Visual Studio Code. You could load the input directly into your IDE and run the software. So right now, it only works if you have Docker installed and work with Visual Studio Code. But from New Year on, we will have a remote debugging capability that you can do it directly from your web browser. And basically, here we see, okay, with this specific input as a string plus 115 whatever, in an EN code, you can get a buffer overflow, and you could step through your debugger and try to understand why this kind of issue is happening. And basically here, you would see that there would be a buffer overflow. And for this, we registered a CVE. And basically, what you could do here now, you could fix the code again, run the debugger, and then you would see that the code is running. Then after fixing the code and it's running on your system, you would commit it again because you are in the same merge request or in the same branch. You could see how you get a successful pipeline going on. And this way, it probably, instead of taking you 3 weeks to find the bug, you can find the bug right away. So basically, in addition to this integration into the DevSecOps, so basically we are continuous integration agnostic, we are build system agnostic, we add this kind of debugging functionality, and this way you can save a lot of time when debugging your code. So you commit the code, 5 minutes later, you see that your pipeline is not running, you run it through the debugger, and 20 minutes later, you fix the bug, the pipeline is accepting the code, everything is good, and you fix the bug. In comparison to the traditional way, like most of the automotives are doing it right now, it took you 25 minutes instead of 3 weeks to just fix this minor issue. So for the people here in this talk, you probably wonder what is required to do fuzzing. So a lot of projects in automotive already can be built, or at least single units can be built for Linux or Windows. So what is required to do the fuzzing for such projects? For AUTOSAR, it still requires a little bit tuning, but if the software is running on Linux, you could even get better results. So for this, I just want to show you what is required. Basically, we do automatic code instrumentation. All we have to know is how you build your software. So we support several build systems out of the box, but if you click on unknown, we might even be, or we are agnostic, because what happens there, every time the compiler will be called, we inject the right flags for the compiler so that the instrumentation can take place. And then if you did that, basically you are ready for fuzzing. But from that point on, you kind of have to define the different interfaces within your program. So, and I just want to show you two examples. One is where you have an API interface where you want to test your API. And the second one where you would perform a kind of system test like fuzzing, where you would even fuzz a socket. So in the first example, it's like a project offering like some JSON parsing. I know JSON doesn't happen a lot in automotive, but it's always like a good example here because it's open source and you can download it on GitHub. And if you go into their unit tests, they already have, I'm making the font bigger so that you can see. I'm just going to the existing code of this project here, providing simple tests for their JSON parser. And there they have a load function. Basically, they get a string, and this string is then parsed in a specific way from the load function. What we want basically what we want to do is we want to know or we want to create a fuzz test for that. So for this, we create macros, and with these macros, you basically create everything what you need for fuzzing. So basically, you have some includes there which are required to get the specific interface running. In addition to that, you also have like a fuzz function. It's like a unit test, but a fuzz test, which you define. And in this macro, you get two parameters. One parameter is the random or the smart mutated data, which is coming from the fuzzer. And since in C and C++ you don't always know how large your object is, you provide the size. And it doesn't just work only for buffers. You could put any C object here. You could use struct or uint whatever, or even a character. And what you could do then is basically you tell how the data is then processed and then given to the function under test. And then you would provide something like data plus size plus how to call it. You save it. Then you would run it through the continuous integration. We also offer some shortcuts to run it, like the continuous integration. You can see it is in the CIs directly from your IDE. Then it would make some compilation checks, whether it can be compiled and so on. And then you can push the code, and then the fuzzer would return the issues. So, but this is just an API example. In a lot of applications, so we talked about Suricata before, or you might write a little server or a client for some specific protocol, or you would write something in Canvas. We could also perform fuzzing on a system level. Basically here, we found a CVE in light HTTPD. It's an HTTP server probably running on your router at home. And there, what we had to do there basically is, if we create a new fuzz test, we also provide more higher level fuzz tests. So in addition to the API tests, we offer network and file descriptor fuzz tests. And for automotive, we also offer some specific automotive software like Canvas fuzzing. And what you would have here is you would provide a stream in TCP. You would give it a name, basically tell what kind of binary to start. In this case, it's light HTTPD. Say what kind of port you would address, what kind of runtime parameters you get, and then everything would be running. Obviously, for automotive, as you know, to get the things running within Jenkins, you require a few more parameters. And if you do that, you basically get, again, the same results that we have seen here. You always go back to your pull request, kind of look whether some issue happened, and if no issues have been happened, you get a kind of code coverage pull request, and you could even have a look what kind on a statement level, what kind of code you covered, and look it up, and even give hinters to the fuzzer. This would go a little bit over the top for the fuzz for here, but if you are interested in using our solution, we could provide you a demonstration going into the needs, what you kind of need in your project. So with this, I would like to conclude the talk. So my personal mission is that I want to take care that a lot of companies will be using fuzzing in future, and not just the tech leaders in other industries are using fuzzing, but also the tech leaders in the automotive industry will find more than 80% of their bugs inside the development process with fuzzing. And with that, I would like to close my talk and open for questions.
Thank you, Sergej. We already have a few questions, and I will start with them. If there are any more questions, just add them in the chat, and I'll ask them in the end. The first question is from Sergej. It's, I believe you briefly touched this. How do you fuzz test AUTOSAR components, and what's the best strategy for doing this?
Yeah, there are two different AUTOSARs. So there is adaptive AUTOSAR and classic AUTOSAR. With the adaptive AUTOSAR, things are actually quite easy because it's very POSIX-like. So there is no big strategy. In a lot of cases, you can even compile the code with GCC and everything works. For the classic AUTOSAR, things got complicated, but we already have a few projects having AUTOSAR, and there we provided a little bit device faking and mocking that it's able to run with on Linux. It usually takes a few days to get all the setup running, but once the setup runs, you get like a lot of bug reports because you stop using hardware in the loop for testing, and you have a far better strategy to do that. But obviously, there are always edge cases where some specific modules wouldn't work. I'm happy to have a one-on-one and talk about the specific use case with you.
Okay, I'll take the second question from Scott before I get to the others. That's, can you comment on the best strategies for fuzz testing embedded specific software on Linux environment x86, 64? He already looked at Unicorn Engine with AFL, for example.
Yes, of course. So actually, we are not focusing that much on our own fuzzing strategy. We even implemented a lot of things. And right now we have a project where a hardware manufacturer is providing a lot of things, and they need to use Unicorn and so on. And what we basically have, so if something is running with Unicorn or QEMU, it is compatible to our solution. So basically, we would take the instrumentation from QEMU or Unicorn and leverage that. And what basically our platform would do is it would scale it on a lot of nodes. It would do all the DevOps integration. But if you have something with Unicorn running, it will be even better with our approach.
Okay, are there any specific strategies if you're testing embedded specific systems, or is it for you it's the same whether it's embedded or not?
I wouldn't say it's the same because for the strategy, what you need to add is that you obviously have to do some mocking. So when you have embedded systems which kind of run an embedded systems Linux, like on ARM64, things are super easy and we can automate almost everything. But once you are starting to use real-time operating systems or start using bare metal applications, you kind of need a few days to do the tuning for Unicorn. Yeah. But I cannot say that there is one generic strategy because for each project there might be another one. So for this, I need just more details.
Okay, and then some less technical questions. Quizo de Guru asked, do the norms explicitly require fuzzing or just resilience against rubbish data?
Could you repeat the question again?
The norms for automotive, do they explicitly require fuzzing or just resilience against rubbish data? For example, the ISO SAE 21434.
Yeah, so there is just the draft right now for the ISO 21434. There are some ways to get around fuzzing, but so it's kind of mandatory how it looks like what will be published. But I'm not in the process. Maybe it will be changed, so we only have one specific draft. If you look to other industries, only the medical, so in medicine, there are a few standards or best practices which require fuzzing. And also the common criteria doesn't require fuzzing right now, but as the rumors go, things will come for all kind of industries.
Okay, that's maybe a bit related. A question from, I hope I get this name correct, Basavaraj Kurugot is asking, what is the demand for fuzzing in the automotive industry? What are your experiences there?
As I said in the beginning, so when we started 2 years ago, we were going to a lot of different industries, and automotive was something like, yeah, fuzzing doesn't work for us, and there was no demand. But this changed in 2020. I'm not sure whether it's Corona related and people want to get more efficient testing, but now we get a lot of requests. We need help with that, and so almost every European manufacturer is already in touch with us or already customer, and so it changed kind of overnight.
Okay. Thank you so much again. I believe those were all the questions. Thank you for your presentation. Would you like to say anything in closing before we finish?
Yeah, in my opinion, so we hear a lot of headlines like security issue here, bug there, and so on. But if you look closely on the specific things, like with the Bitdefender today, but also other bugs, you notice that most of the issues which went public could have been found with fuzzing. And I think that in 2021, we should stop releasing software where there are security issues which could have been found with fuzzing, because we have the techniques, just use it.
Okay, thank you. Thank you everyone for joining this week. We hope to see you next week in the next webinar from ASLT World, and have a nice evening, nice day, nice morning, wherever you are, and see you next week.
Okay, see you. Bye-bye.
Ciao.
Ciao.
So,